Welcome to the Peel 3D scanning for MyCRO Band. My name is Gabrielle Williams, Sales Applications Engineer, and I'm joined here with Jaime Pineda, CPO of Cranial Clinical Specialist for Ottobock. Just a little warning, you guys, we are going to be recording this so that if you do want to watch this at a later date, we will be sending it at the end. Also, just please get acquainted with the panel. Here you'll notice there is also a little question area here in the meeting. And so if you do have any questions at any point throughout the webinar, you can just ask a question. And at the end, we'll be able to answer those questions. So feel free to, type in something at any point. So let's go ahead and get started. So I already gave a brief introduction, but JP, could you introduce yourself a little bit further?
Yeah, sure. Thanks so much, Gabrielle, and thank you so much for Peel for this collaboration. As part of Ottobock, we're really excited to be doing this. We did a similar version of this presentation at ACPOC earlier this year, and our partnership goes back many years with the first Peel 1 scanner, which we validated for our 3D printed helmet. Now we're really excited to learn more about the Peel 3D, which is the newest version. Again, I'm JP. My first name is Jaime, but I go by JP. I'm a CPO. I've been a CPO for 12, 13 years. And during that time, I've specialized heavily on cranial remolding helmets. And I've been with Ottobock, I think like over 3 years in this role, providing support for our 3D printed helmet.
Awesome. Thank you, JP. And I'm Gabrielle Williams, Sales Applications Engineer for Peel 3D, located in California. And I've been with Creaform and Peel for about 8 years now. Started as an applications engineer, then went to customer solutions expert, and now I'm very happy to be a part of the Peel team as a sales applications engineer. All right, so go ahead and take it away, JP, and then later on the other half, I'll continue with the Peel side of things.
Cool. So yeah, we just wanted to give you guys just an introduction of the things we're going to be talking about today. I'm going to be starting the talk. I won't talk for very much. I just want to give everybody just an introduction on our 3D printed cranial remolding orthosis. So a little bit about the project history, where it started, digital fabrication. I think for folks who are not familiar with 3D printing, it seems like it's everywhere in O&P these days. So just kind of an overview for people who are not as familiar. We'll go into some specific on the product details on the MyCRO, scanning and ordering. Obviously a big part of that will be Gabby's part later on, fitting and modifications, and then the steps to certification.
Yeah, and then as far as the Peel 3D side goes, we'll be talking about the 3D scanning techniques and applications in the healthcare sector. I'll do a quick introduction on the Peel 3 scanner. I'll go through the scan procedure, how to save the data, how to clean up the polygonal STL, that's the file type that we use in the software, and how to export that file to help build a perfect fitting helmet with Ottobock. And then also we'll go over some other examples of medical applications.
Cool. So the MyCRO Band is the first FDA-approved 3D printed cranial remolding orthosis in the US market. We know that there's tons of other 3D printed cranial remolding orthoses now, but we're pretty proud that we were the first ones. The project, though, was started off in 2018 at our Ottobock partners in France. So MyCRO Bands have been fit on babies for now over 7 years. It was brought over to the US pretty early on in the project. So we received our FDA Class 2 device approval in March of 2021. So over 4.5 years at this point. And about 6,000 MyCRO Bands have been fit on babies in the US. So we've learned a lot from bringing this product over from our colleagues in Europe on how to fit it. There's been several iterations of it, and then also how to manufacture it. We brought the manufacturing over to Salt Lake City. So it's been a great journey so far. Now let's talk a little bit, before I go into kind of the introduction on the MyCRO, let's talk about just overview digital fabrication as an entire process, and then some of its benefits and how it differs just slightly from traditional manufacturing. Especially everything that I'm saying will be in relation to cranial remolding orthoses, but I think could apply to other O&P devices that are 3D printed as well. Kind of like what I mentioned earlier, it seems like 3D printing is everywhere. If people have been to the recent kind of large O&P conferences, there's tons of 3D printed devices now, and really the reason is that these devices can be a lot more accurate. So kind of the three main parts of this process is the scan. Obviously, this is where kind of the folks at Peel come in using a really high quality scanner to scan the baby. Then that file is sent to us, the manufacturer, for the CAD creation. This is where we're designing the micros, and then we're sending that file to our 3D printer for fabrication. So if you take a look at that process, it's basically a digital process all the way through until you get your actual device. So again, that means that there's no model that has to be basically built to be able to drape the plastic over, or there's not somebody else having to fill your cast with plaster. So the process ends up being a lot more accurate. So what that means in practice is that these helmets are fitting a lot better on the babies out of the box, let's say. Okay, you don't have to do nearly as many adjustments because of that. So one of the biggest benefits to digital fabrication is the accuracy. Okay, the other thing is the material itself that we're using to 3D print. It starts off as a powder. Once it goes through the 3D printing process, it turns into a rigid nylon. And depending on how it's fabricated, it can be a lot thinner and it can be lighter. So in cranial remolding orthosis, this application it's not as heavy on the babies. And for parents, potentially could be more compliant because they're seeing these helmets as not being nearly as cumbersome for their baby. And we know compliance is huge for CROs, okay? The other benefit that I can kind of bring out is just kind of aesthetics, right? If you even take a look at the other 3D printed cranial remolding orthoses in the market now, everyone has kind of gone a different way, but they look very different than the traditional plastic helmets. So improved aesthetics. And then the last benefit that I'll point out is decreased in waste. So the powder that we use to 3D print can oftentimes be reused in future runs, as opposed to a lot of that plastic that ends up being cut off in the traditional manufacturing process that just goes into the garbage. So overall, kind of a really cool new way of thinking of O&P, and I think especially relevant when it comes to cranial remolding orthoses. So, okay, cool. Finally, we have our micro. I have a few pictures kind of to show. I also have one here with me to kind of show it a little better when pictures don't do it justice. But let's start with the shell, because this is the part that's actually 3D printed. Again, like I said earlier, it starts off as a powder. This powder is called PA12. And after the 3D printing process, it turns into a rigid nylon. So kind of acts similar to copoly. It can be trimmed, it can be heat moldable, okay? And then in this case, it's 60% thinner and up to 40% lighter than conventional helmets. So like I mentioned, that can be a big benefit for the family. As you can also see, our micro is a much more open at the top than traditional helmets. Kind of our philosophy here is if we only have to grab onto the baby in certain areas, we can leave everything else open, and that's going to help us with the weight and then also just breathability in general. Next, let's talk about the lining. We went a slightly different way than some of our other competitors. We went with a removable fabric lining. Part of this is people who have been doing cranial remolding orthoses for a long time know how smelly and how stinky these helmets get. So kind of our thought process here, it's let's have a removable lining so that parents can be washing one while the other one is being worn. So parents get two of these. The fabric is really soft. It kind of feels like velvet. It's a synthetic material though, okay? And it attaches to the shell with Velcro. So the inside of the shell is filled with Velcro. And that's how the fabric attaches to it. As you can see, there's always roughly 1 centimeter of fabric exposed through all the edges so that there's no hard edges touching the baby. And then lastly, we have our closure system. We call this the MySize closure system. Also kind of reinvented the wheel here. We're not going the traditional strap and Velcro route. We have basically a self-expanding latch that accommodates for head growth. So Gabby, if you move to the next slide, this picture shows it a little bit better. So it's a latch that expands slightly. You get 2 extra centimeters of circumferential growth, and it's the elastic band that has the force to keep the helmet closed. So you have that extra 2 centimeters of circumferential growth if the baby goes through really rapid growth or maybe grows a lot of hair during treatment, but you could potentially have a MyCRO that stays closed the entire time. Okay. We did recently have an update to the product. It's that little picture on the bottom. Instead of having the latch be kind of open where you see that little tab, it's all closed. So here's the live sample of it. You can see it's all smooth. And then this is, if needed, the helmet, the helmet can open up this amount to give you just some extra growth. Okay, so we kind of reinvented the wheel when it comes to how the MyCRO Band is made and how it presents, but not on the design principles itself. We did not reinvent the wheel when it comes to cranial remolding orthosis treatment. We might call things slightly different names. Again, Ottobock's a German company, so sometimes the translations are words slightly different than I think what we use in the US, but we have our contact zones. This is what defines the limits for growth, and our 3 head examples on the bottom. We have these as the green arrows, those just our holding areas. And then we have our growth zones. This is the space on the inside of the helmets to allow the baby for the head to reshape as the baby grows. And then our 3rd design principle, I would say, is slightly more, this is the next slide, Gabby.
Do you see the new slide or no?
Yes, now I'm seeing it. Okay. Thank you. Our 3rd design principle, I would say, is more unique to the MyCRO, which is what we're calling grip zones. This is just where the orthosis stays in place and prevents rotation. We have 5 total grip zones. So you might notice, especially as you see pictures of babies in MyCROs in this presentation, or also as you start fitting them, you notice that it just fits more snug around the baby's cheeks, a little bit under the occiput, a little bit more. And part of that is to help us kind of prevent the MyCRO from rotating. Part of this too, if you see some really, really good fitting helmets, part of that is the accuracy in the design that I mentioned earlier. And then another part of that is the grip zone. All right, so who is the MyCRO Band for? Nothing here should shock people that do this day to day. Babies between 3 to 18 months. Of course, we understand that the younger, the better. The younger, these babies are going to change faster and get better outcomes. And then moderate to severe plagio, moderate to severe brachy, and then moderate to severe combination head shape. And then if you were paying attention, there's one head condition that we currently don't treat with the MyCRO, which is our scaphocephalic head shapes. If there are babies with asymmetry that have a scapho head, we can correct for the asymmetry, but not for the proportions, okay? Obviously, babies outside of this age range, the 3 to 18 months, we cannot treat. Also, not pre and post-surgical craniosynostosis. We're not a surgical band. And then, obviously, unshunted or uncontrolled hydrocephalus as well. Cool. So ultimately, the 3 different types of head shapes that we treat, each of them get a slightly different trim line. But of course, if clinicians are used to something very specific, we can try to accommodate that in the orders, but we have our plagio trimline helmet, our brachy helmet, and then our asymmetrical brachy. And then the MyCROs generally open on the side opposite the flatness. And then for customization, this is always really fun because we know parents want to make their helmets for their babies fun, especially when they're going to be in this for a couple months. So gray is how the MyCROs come out of the 3D printer. This is just how the rigid nylon comes out, but we can dye the material either blue or pink, which are the little examples on the bottom right. And then the fabric can also be customizable. So we have the all black one that you're seeing here on the slide. And the ones that you've seen in previous slides is what we call the berry, which is berry touching the baby, black touching the helmet. So 3 helmet colors, 3 lining colors, and then we have 40 little emblems that can be engraved on kind of that top cap. So you can see that is the little whale, And then the other icons are kind of on the smaller side, but a lot of cute animals, or no engravings if the parents doesn't want one. The micros can also be painted with acrylic paint. Stickers don't attach as well as they do with traditional helmets, but especially those really creative parents, they can definitely use acrylic paint to even customize it even further.
Okay. Do people, a question from my side, I'm wondering, do people ever like sign it kind of like a cast ever?
Yeah, I think parents get so creative when they do these. I used to fit a lot of these before I joined Ottobock, and there are some really creative parents that do landscapes that make them into kind of little aviator helmets, or write the baby's names. Yeah, really cool what parents can do with these.
Very cute. Thank you. All right, so thank you, JP, for that portion. I know at some point I'm going to ask for your help again because I have some slides that I'd like you to cover as well. But for the next few slides, I'll be talking about the scanning and the ordering. Oh, wait, sorry, that's you. Sorry.
I think this is still me. I'm just really briefly talking about this. Obviously, Gabby's going to go into a lot of detail. This is just more really broad overview of basically what it takes to order one of these. So obviously, you take your initial scan. Again, our great partner, Careerform, is the broad company. I know sometimes I'm still confused. Careerform, but Peel 3D generally kind of live within each other. There's a lot of different iterations of these scanners. Sometimes they're called different names based on who sells them. So for example, the Omega scanner from Ohio Willowwood, or the body scan, the original Peel, the Peel 1, which looks a little bit different than the newest Peel, the Peel 3, which is also called the body scan 2. And then you're grabbing that file, that STL file, and then you're uploading it to an Ottobock website to actually order the MyCRO. This website is actually changing January 1st. It's currently called the IFAB Customer Center. And by January 1st, it's going to be called the Custom Fabrication Platform. Okay. So for people who are ordering a lot of these currently, or who are going to, if you want to get into doing micros before the end of the year, you'll have to create an account on this website that is going away, and then a new account will be created January 1st. And then one of the biggest benefits to this ordering platform is that clinicians can generate measurement reports. Clinicians who do a lot of these know how important measurements are to track outcomes, to track change, to send to insurance for verification. So both the current website and the new website will give you ways to generate measurement reports. These are really detailed reports that give you all the data that we're used to seeing: circumference, cranial vault asymmetry, cranial vault asymmetry index, cephalic index, severity scales, as well as the next slide, which are comparison reports, basically being able to overlay the initial scan to maybe mid-treatment or final treatment scan. Cool. And then this is kind of my last section, which is basically what it looks like to fit and modify these. This is kind of what clinicians get after placing an order. It takes generally 5 to 6 business days to get these. These are shipping from Salt Lake City, so depending on where you live in the country, you will get a fully assembled MyCRO with an extra lining that you will be able to talk to the family about, 2 extra elastic bands. One should last you during all of treatment. You get 2 extra ones just in case it breaks or somehow it dislodges. Keep those with you. Don't give those to the family. And you get all of that in a bag, as well with a measurement report and the instructions for use that people are familiar with Ottobock products. And then during the delivery, really a lot of the same things that you're doing with traditional CROs. You're making sure that it's not covering the baby's eyes, that it's not folding the baby's ears, that there's enough clearance at the neck for full range of motion. And then you're just ensuring that there's roughly 1 centimeter of exposed fabric so that there's no part of the material touching the baby. And then if you do have to do something to improve the fit, remove the lining. The shell is fully trimmable with a Troutman. Can also can be heated and flared if needed. The outer layer, which is a little thinner, is a little easier, but you could also do it to kind of the thicker intersection. And then you can also add pads. The thing about pads is now you're adding a pad between the shell and the lining. So just make sure that you're adding a piece of sticky back Velcro on top of the foam so that the fabric can reattach. And then again, super dependent on baby's age and severity, but generally these will last anywhere between 3 to 6 months, and then follow whatever follow-up protocol you're familiar with. We recommend anywhere between 3 to 6 weeks, depending on baby's age. The younger babies being followed up more often, the older babies being followed up a little longer. And then my last slide here before I turn it over to Gabby is just the steps to certification. For folks out there who are interested in starting to do these, you have to complete a My Learning certification, just like how you do any other Ottobock product, you have to get certified. And then we have a certification course on My Learning. You get 3.25 ABC CEUs. It probably won't take you that long, especially for people who are familiar with this type of treatment. Then you have to create, again, an account for the ordering portal, currently the ICC. And then after that, depending on how much training you need, you follow up with me or my colleague Blake on in-person or virtual training. And then you're ready to scan and order.
Awesome.
That is all for me. Now it's Gabby's turn.
Awesome. Thank you, JP. Appreciate it. All right, so now I'm going to go into more detail on the 3D scanning techniques and applications. So some of the stuff that we'll learn is that we'll equip you guys, the medical professionals, with the knowledge of how to leverage cutting-edge 3D scanning technology to provide patients with form-fitting helmets, individually perfect for them. And we'll also discover other medical applications for 3D scanning. So let's talk a little bit about Peel 3D, which is the entry-level brand of Creaform. And Creaform's been around for 20+ years, and throughout all those years, we've learned of so many different types of reasons our customers can use 3D scanners. So not just with medical applications, but also with museums, film, automotive industry, aerospace, and a lot more. So really anybody with a great idea should have a way to access high-quality 3D scanning technology, and this is why Peel 3D was founded. So just quickly going to touch on a few medical applications. So in this webinar, we'll talk about the orthotics and prosthetics, specifically the cranial scanning, but you can also have applications such as pediatry, mastectomy, plastic cosmetic surgery. So in this example, someone with a rhinoplasty was able to 3D scan themselves before and after, and you can really see how much difference there is there. Mobility assistance is another thing, and then 3D archiving if you want to save the files of the before and after surgery. And then of course there's other applications too. So let's talk a little bit about the 3D scanner itself. So if you see there on the leftmost picture, we have a few cameras. So there's a top and bottom camera. Those are going to be the geometry cameras. So you have the top one and the bottom one here, and that's what actually sees the surface. Then if you do need to scan in color, you have this camera here, and you have some LED lights as well if you need to shine the light on the subject. And then we have an infrared projector. So this infrared projector displays a pattern onto whatever it is that you're scanning, and depending on how that light, kind of patterned up forms and changes, the geometry cameras are able to see what is happening on the surface of what you're scanning. Then if you turn the scanner around, you'll see the LCD touchscreen. That one is going to have the ability to start scanning or stop scanning, zoom in, zoom out. You have the shutter mode, and you have fit to screen. And then at the top, it'll tell you what your distance kind of meter is. So green is good, you're at the right distance. And if it's red, it's too close. And if it's blue, it's a little too far. If at some point it doesn't see anything or doesn't really understand what it's looking at, it will give you a little question mark right here. It also has haptic feedback, so if at some point you're no longer scanning and you need to return to a location that it understands better, it will vibrate to let you know to maybe pay attention to the screen and kind of try to match everything up together. Okay, so let's talk about some of the Peel 3D scanning benefits. So first off, it's fast. And when we're using it in the medical applications, it's going to shorten the consultation time, which is going to lead to more patients being able to be treated. Also, we have automated post-treatment. So this 3D surface is generated as you scan, so you can really see it live as you do it. It's user-friendly, so it has a very short learning curve. We even have little videos that pop up as you hover over the different buttons, which helps you, be guided to what it is that you're about to do. And it really doesn't matter your experience level, so you can really learn as you go. Also, it's innovative. The data files can be sent rapidly and securely over the internet to remove fabrication center and to a remote fabrication center to optimize the machining process. It's also clean. It's a great alternative to traditional or possibly tiresome and messier casting methods. And it's non-contact. So it's non-invasive 3D scan process for minimal discomfort for the patient. And it really is portable. It only weighs 2.1 pounds, or for European guests, it's 0.95 kilograms. And then as far as accuracy, it does have an accuracy of up to 0.05 millimeters or 50 microns. And the reputation and the experience of Creaform, Creaform has a worldwide reputation of 20 plus years of experience. We've been around for a very long time, and we have great customer service. So JP, could you explain a little bit about what the current processes are if you aren't using a 3D scanner?
Yeah, of course. So I kind of alluded a little bit to this. The slide comes from again, Gabby, and it's really nice because it's really detailed. So if you think about, especially on the prosthetic side, you're taking a cast of the residual limb, you're sending that cast maybe to a lab, or you're doing it yourself. You have to fill it with plaster. Then you have to store, right, all of these casts just to be safe. Then you have to modify your plaster cast. Then you have to drape the plastic over. You're potentially maybe sending that out to somebody. So there's a lot of shipping that happens back and forth. Maybe when you get it back from, if you're sending it to a lab, maybe something got damaged, or maybe something didn't fit quite right, so you have to send it back. So there's just generally a lot of back and forth that happens with traditional kind of fabrication methods, that when you scan that digital file, kind of saves a lot of time and effort.
Thank you. All right, so here's a quick little video of this is the Peel one, but you can see we're scanning a little baby, just shining the cameras directly towards the cranium, and we have little target markers on there to try to keep track of where it's been looking. So the process of what that looks like is you're going to be scanning the baby's head using the Peel 3. Step 2 is you would clean the mesh, just get rid of any spikes, any bumps, or you can fill holes if you need to on the scan. And then you would send the file to Ottobock, and they take care of the rest from there. So Ottobock at that point will design and send the fitted microband. So typical scanning workflow. First, you just connect the system. So you can connect the scanner to a computer and a power outlet, and you launch the software. Then you set your parameters, which we'll go over in the next slide, specifically for your application. So if you're scanning a baby head, we'll go over those parameters. And then you're going to be doing the scanner calibration. If you're going to be in a clinic, that has specific kind of air temperature all the time, same air conditioning, you don't have to do it that often, but it will require you to do it maybe once per week, just to make sure that, just in case anything did change, it just asks for that. And then you would scan the baby. You would scan by directing the cameras towards the baby's head and all around, with the scanner about 15 inches away. And then after that, you edit the mesh. So you use the tools available to remove spikes, fill holes, and so on. And then you save either the session, if you do want to reopen the file at a later time and edit it more, or you can just export the mesh so that you can send it to Ottobock. And that would be a .stl or .obj file type. As far as the scan parameters go, when you are scanning a baby's head, we recommend that the setting for object, instead of tiny, small, medium, or large, you set it to human body. So that'll change some of the settings to make it better for human body, such as, turning off the lights so that you're not having lights being flashed or anything. And then as far as color, you don't really need color, but you can scan in color if you want. It'll just take a little bit more processing time. And then resolution, we recommend about 2 millimeter resolution. That's the size of the triangles. And you can keep smart resolution on off. These are the settings that we recommend.
Yeah,
and then we have the scanner. Oh yeah, go ahead.
The slide went off for me. I don't know if other people are able to see it, the presentation.
Oh, let us know if you can see the slides. I'm going to see, and you can have a little chat. There's a little chat icon at the top there. So please let us know if you can still see it.
Now,
we can see, now, yes, now we can
No.
see it, Gabby.
Okay, good. Thank you. Perfect. Okay, thanks, JP, for letting me know. Okay, so scanner calibration. So we have the scanner calibration plate that comes with the 3D scanner. You would just remove it from the lid and place it on the gray box. And then just when you're in the calibration mode, you just follow the images on the screen. So you can see there that there's a little ghost image of a Peel 3. So you just align your actual Peel scanner to the ghost image and you shine the light directly onto the calibration plate with the different moves that it requests. Okay, so on the next video, I'll go through and talk about a 3D scan. Now, I didn't have access to a real life baby, so I did 3D scan a baby doll, but I'll go through what that looks like here. So first off, you start off with your settings, set it to human body. So, I like to set it at watertight as well. That way it fills all the holes for me. And then you can set the resolution to 2 millimeters. So here I am, I've just pressed play on the scanner. You can see I'm just angling the cameras directly to the baby's head. And the green is telling me that I'm at the right distance. Red is telling me I'm too close and I can back up a little bit. And then I just go all around to get as much as I need. As long as you get everything that's on the cap and a little bit of the ears, it's really all you need. You know, the face can help too, just so that Ottobock knows what they're working with here. So at this point now, I'm just using some of the editing tools. So we have the paintbrush tool here where I'm just disconnecting the cloak from the baby's head because we just really want to send the head to Ottobock. And we just highlight the baby's head, invert it, and delete here. At this point, you can see that I just click on the next step. You have a lot of the steps kind of just done for you. So here, since I chose watertight, now it filled in all the holes, and then now here I'm using the defeature tool to kind of just blend any spikes. For example, the cap, the nylon cap had a little bit of excess material there, so I can just use the different selection tools to highlight things that will allow me to defeature those surfaces. Okay. Once you have that, you just export the file and save it, and then you send it over to Ottobock. Okay, so let's talk a little bit about some 3D scanning applications. JP, if you could help me out with this slide.
Yeah, I think kind of the benefit to a scanner like this is, of course, you can use it for, it's great for cranial scanning because it's able to track the moving baby, but you can also use it for anything else. You can scan for TLSOs, for AFOs, for obviously prosthetic, any residual limb, basically anything in O&P, foot orthotics, and send to whatever manufacturer. So obviously this is not just for cranial, and obviously there's kind of what Gabby said earlier, there's a lot of non-O&P applications, but within O&P, it can be kind of your go-to scanner for basically anything that you do.
Cool, thank you. And so here's a quick little video of a leg scan. This was done with the Peel 2. So yeah, like we mentioned, this allows for a one-time visit and files can be stored in the computer. That way you don't have to have the the client come back over and over in case they need to refit anything, but you have the file already saved. You can refer to that. Here's an example of a foot scan. So if you need to get a foot scan, you need the top and the bottom of the foot. There are plexiglass frames that you can get, so that way you can scan the top and then the bottom. And we've just placed targets around, on the frame. We've also placed some on the floor there, so you can come around and then scan the bottom of the foot and then align and edit from there. Here's an example of a no scan. So somebody had the rhinoplasty done, so you can see 1 week before surgery, during 1 week after surgery, and then 1 year after surgery, and you can really see the difference between all. So at this point here, that we were 3D scanning the subject, starts off there, and so as you go around, you can just angle the light around, and then just get the surface as you need. So as you can tell, in this case, we were scanning in color. So you can see the color there. But this is before the surgery. I'll skip ahead to show what that looks like. And this was, once again, with the Peel 2. So then we'll zoom in there. And then after that, we show also the 1 week after surgery. So here you can see it's a little bit more swollen still after the surgery was completed. And then finally, 1 year after the surgery. And this was done so that the subject could breathe a little bit more clearly. After that, we took all 3 files and then we were able to overlay them on top of each other and do a color map and see the deviation between each one. So here, everything that's in green is within 2 millimeters, and then here I'm lowering it. So now it's within 1 millimeter. So anything that's outside of the 1 millimeter difference, 3D difference, is not in green there. So here you can see it's a 2.8 millimeter difference between the before and the after the nose surgery. Here's a little bit more additional information. We're getting towards the end of the presentation here, but you can find this information also on our website, peel-3d.com. But the technical specifications, you can find them here. It's going to be, for example, for the software, it's going to be peel.os, and that's the one that you'll use for cranial scanning. But you'll find items like mesh resolution, 0.25 millimeters, scanning speed, 80 seconds per meter squared, and so on. And then, of course, if you do have a powerful computer, a great computer, then the better the computer, the better the faster the Peel 3 will scan. So we do have the recommended specifications on our website as well. Yeah, so we'll open it up to questions now. For reference, we do have our email addresses here. So if you do need to contact us at any time, you can also email us there. But oh yeah, Livia here is going to be, she's from the Peel team. She's going to be asking us some of the questions that she's had throughout the presentation. Thank you, Livia.
Thank you all. And I do have one question for you, Jaime, from our customer, Carolina from Brazil. Why you don't use it for post-op cranial inostosis?
Yeah, that's a great question. So yeah, our MyCRO Band is not indicated for post-op. Part of that is because we don't treat for the scaphocephalic head shapes, the helmet has to be redesigned just slightly. The most common type of cranial synostosis is the sagittal suture fusion. So you need a really strong front and back hold. Because of our elastic closure, we just don't have that currently. And then also in the US, it requires, again, FDA approval. And so it's basically a whole new process. We are looking at it, so probably in the future we will, but currently you can't.
So I hope you answered your question, Carolina. If you have others, please put it on the question panel. And we have another question from Marcio. How do you process the scan data to create a custom cranial band or orthosis? Go ahead, Gabby.
So there's a few things you can do. I showed that quick video, but there's things that you can do like remove spike. You can do things like defeature, fill holes. You can choose the watertight option to make sure everything's already, going to just get filled in for you. There's even a little sandpaper tool. So if you do want to smooth out certain surfaces, you can do that as well of the mesh. But then after you're done with that, really all you do is just click the next button. At some point, it will ask you to export, and the software will do all the finalization stuff, and you can export the STO. If at some point you do want to go back and edit more, process more, you would just make sure that you save the session file. So that would be the .p3d file.
Libya, is this participant in the US or outside the US?
It's outside the US.
Okay. Another, I think probably maybe what they're getting to as well is how the helmet is made. In the US, there are some pretty specific rules that the manufacturer actually designs the helmets, not the orthotist like they do in some places around the world. So that's kind of what Gabby was saying. You basically send Ottobock the most cleaned up scan that you can have, and then Ottobock has its own process within a CAT software to design a helmet based on the specifications that that customer submitted through the ordering portal. So
thank you, Jaime. And I have another question here. Maybe you have already answered, but let's say, what are the steps for integrating Peel 3 scans into Ottobock software for cranial remodeling?
I don't think there really is any integration. You just do the Peel 3D stuff on your own computer, and then you send the file to Ottobock, and they take care of the rest.
Do you guys know what output file will get into the Ottobock software? It's an STL file normally?
yes, as an STL file, I would say the only integration potentially is when you're generating a measurement report within the Ottobock ordering portal, because there you are manipulating the scan just slightly to place anatomical landmarks like the tragus, the nose tip, the eyes. You're guided through a process that at the end gives you that PDF of the measurement report, but there really is no integration other than that.
Thank you. We have other questions here. Can this be used with a shunt? I don't know really what that means. Maybe you, Jaime, can explain that.
Yeah, so a shunt generally are for babies with hydrocephalus, and basically the shunt is like a little tube that helps drain the fluid out from within the head. I would say we are not contraindicated to treat babies with shunts, but I would just say use your clinical judgment with these. I would say that I think a traditional helmet might be a better fit for these babies because we have to ensure that there's absolutely no pressure on the shunt, and that can be much easier to do with a traditional helmet because you can actually carve out the groove or deepen the groove as opposed to a 3D printed helmet where, yeah, we can give you where the shunt is, but it's not as adjustable as it would be with a traditional helmet.
Perfect. Gabby, I had a questions about the lighting on your video, but somehow I lost it. Can you explain what are the setups to remove the light on the scanner?
Yes. So if you noticed in the previous video, the Peel 1 had some lights going, shining onto the baby when it was 3D scanning. But with the Peel 3, now you can turn that off. So if you do want to keep the light off, you just make sure that it's set to human body setting and the parameters in the beginning, and that'll make sure that the lights don't flash in the baby's eyes. The lights are eye safe, but you know, in case you just didn't want that to be happening, you can turn that off.
Okay. And one other question. Go ahead, Jaime. Do you have other points?
I would say like I'll just bring that point up again, because with the Peel 1, one of the biggest concerns that people brought up is like once the baby sees the bright light, they just like can't, they're like kind of hypnotized by it. So it's a really great feature of the newest Peel that light can be turned off or is not as bright, so to not interfere with kind of the scanning process. So I think that's great. It's a great update.
Perfect. Thank you, Jaime. And so Gabby, another question for you. How do you handle movement during scanning? What are the best practices or tools to minimize errors?
There's a few things. First off, the human body thing helps a lot, the human body setting, because it allows for adjustments or movements sometimes. And then also the placing targets onto the baby cap, like if you noticed on the baby's head, on the little nylon cap, we had some little sticker targets, and those are little reflective markers that allow for the scanner to see better. So if at some point you have a hard time seeing the surface while you're scanning, just place a few more targets, and if it sees a few more like as a pattern, then it'll be able to track better. And make sure also in the settings, if if you depending on which version of the software you have, there is one option that allows you to make sure that you're scanning with targets and geometry. So make sure you're also doing that too, just because there is sometimes people might accidentally set it to targets only, so it's not really looking for the surface, but targets and geometry is helpful.
Thank you, Gabby. I have another question for you, Jaime, about the MyCRO Band. Where are the MyCRO Band CRO manufactured?
Yeah, so our manufacturing facility is in Salt Lake City for the US. And then in Europe, there's one in Chablot in France, and I think the other big one is in Duderstadt, which is Ottobock headquarters.
So another question related to this question, can Ottobock ship MyCRO Band helmets to any location worldwide?
Not currently. It's based on whatever market you're in, if the product has been released to that specific market. So in the Americas, currently it's only the US. And then in Europe, there's a few markets, Germany, France. I can't think of the other ones off the top of my head, but currently it's not available anywhere in South America, Central America, and then basically outside of Europe, not yet.
So do you guys have any distributors or clinics worldwide?
So it depends. Each market is a little different. Ottobock, again, the manufacturing part of it is different than the patient care side of it, and it depends on where you are in the world. So in the US, Ottobock does have a few clinics. So if you're US based, you can basically just Google search MyCRO Band certified sites, and you'll get a list of sites, both that are owned by Ottobock and independent customers as well. And then I would say it's similar to outside of the US.
Thank you. I do have other questions here, Jaime. How long after order submission does the MyCRO Band take for fabrication?
Yeah, so in the US, there's a pretty specific kind of guideline by the FDA that cranial remolding orthoses have to be fit within 14 days of the measurement scan. Part of that is babies are growing so quickly. So if you make a helmet off of that initial scan, the baby would grow so much if you waited too long. So if you scan the baby, place the order, that MyCRO will be manufactured between 5 or 6 business days, depending on the time of the day that you order it, and then you account for shipping time. So you're well within that 2-week timeline. You should be getting the MyCRO in your office a day or two, depending on how far you are from Salt Lake City.
Thank you, Jaime. And do the MyCRO Band have a warranty?
There is a 6-month warranty on these. Typical things, poor fit, excessive redness that goes unresolved. If it cracks by any means, yeah, 6-month warranty on these.
6-month warranty. And the last one, what other colors are available for the MyCRO Band?
So again, gray, which is the picture that you're seeing right now, is how the MyCROs come out of the 3D printer, but we can dye them blue or pink. And then that pink looks kind of more like a berry, but those 3 colors.
There is another question here. Maybe, Jaime, you can help me with that. Can you talk about what makes this better or different than the Cranial Technologies 3D helmets?
Yeah, I'm actually, the Cranial Technologies 3D printed helmet must be pretty new. I'm not familiar with their design. I can't speak to theirs. But I would say if you look at our 3D printed helmet, even compared to, I think there's 3 or 4 other 3D printed cranial remolding orthoses, you can see that we're still the thinnest out of all of them. We have the removable fabric lining as opposed to all the other. So I have still a foam inner lining, and then our closure is still totally different. We're a single closure CRO, as well as we have that expandable latch.
I hope that answered your question, Heather. So I don't have any other questions here. If you guys have other, please put it. If not, we'll make sure to come back to you guys with answers. And I think it is from my side is all the questions I have for you guys today. Thank you for answering the question. Really great. Thank you. I think you're muted, Gabby.
Thanks. There's a little echo earlier, but all right. Thank you, Olivia, for asking the questions. And JP, thank you so much for hosting this with me. It was a pleasure having you here. Thank you to everybody that was able to attend. And once again, we will be recording this, so we'll be able to share this with you as well. But please feel free to reach out to Ottobock or the Peel 3D team with the emails you see here if you have any further questions. Thank you so much, everyone.
Thanks, everyone. Thanks, Gabby. Bye.
Bye.